Hey, and welcome to my final video on Blotter.js. In this video, we're going to look at how to make our text react to mouse movement. In our final design, when the mouse is over on the left-hand side of the screen, the volatility of our blotter animation is low. As I start moving the mouse over to the right-hand side, we can see that the volatility of the text increases. So we need to figure out how to somehow tie the mouse position and the volatility of our animation together. Let's take a closer look at the values uVolatility should take. I'm going to head over to Blotter.js again to find this out. Click on Materials and over to our Liquid Distort material. In the top right hand corner again we can see that the values go for uVolatility from 0 all the way up to 1. So we need to get a number between these two values from the position of our mouse. But how do we actually find the mouse position? Well, we're going to be using a jQuery method called mouseMove, and we can see how to set it up in our jQuery documentation. We start by adding the $, as we can see down here. Scroll down a bit to say that we're talking to jQuery. We then add a set of rounded brackets with the target elements inside. We then add a dot and the mouseMove method, followed by a set of rounded brackets. So let's head back over to our JavaScript and go ahead and start finishing off our project. I'm going to add it at the bottom of the screen, just below where we left off our last piece of code. So I'm going to hit enter a couple of times. Make sure you've got the brackets from the previous two functions below where you're adding this code. And we'll start by adding that jQuery symbol, followed by some rounded brackets and the word body, or in quotation marks. We're then going to add the dot with mouseMove, followed by some more rounded brackets. Inside of these brackets, we're going to pass a function that takes the mouse event, like so, followed by some curly brackets. Now, I'm going to hit enter a few times to open these up, and we're going to write some code inside of here that tracks the mouse movement. Every time a mouse moves, this function is called, and we actually can get access to the mouse event by using this event keyword. From the mouse event, we can get page X and page Y values. Now, these values basically pinpoint the exact position or mouse coordinates on our page. So let's print out our page X values to test the range of values that we get from our horizontal mouse position. To do this, it's fairly straightforward. I'm going to do console.log, then the event word, and .pageX. Okay, so let's check for those values. I'm going to click Publish, and then click on our starter project again. Okay, so here's our site. I'm going to right click and hit Inspect, which should bring up our developer console. I'm going to go ahead and click on console, and as we can see, we've already got some values inside of here. Remember, these are the page X values and are recording the horizontal position of our mouse. We're looking for a range of values here to try and match up with our range for volatility, which is between 0 and 1. So let's start over on the left-hand side. We can see that the minimum value is 0, but as we move across the page, we can see that the maximum value tops out at around 1,432 pixels. Now, this is obviously a lot bigger than 1. So we need to try and figure out a way of changing this range into a number that will sit between 0 and 1 so we can set the volatility. Let's start by trying to save the minimum and maximum values that we get from page X into a constant. I'm going to head back over to our starter project. And we can log out or delete console.log from in between there now. And I'm going to write const. I'm going to call these values the range. And it's going to be an array, so I'm going to use square brackets. And we're looking for the minimum and the maximum range that our mouse position could be. So we know the minimum is 0. And then we saw there that roughly the maximum position was something like 1,470. Now, there's a problem with this. Obviously, our screen sizes can vary. So at the moment, I'm working on a MacBook. So that's why the large number is around that size. But we want this to apply to lots of different screen sizes. So adding the maximum value or hard coding the maximum value is not the best way to do this. Now, there is actually quite an easy way to measure the size of our window. We can use window dot inner width to essentially manually record how big our window is depending on the screen size. So this value will always change depending on the width of the window, which is perfect. The next thing that we need to track is the actual mouse value currently. So I'm going to do constant again, and I'm going to call it value this time. And I'm just going to set this to what we were printing out earlier, which was event.pageX. Okay, so we've got the range and we've got the value. Now we need to write a function that changes the value into a number between 0 and 1. In programming, this is actually fairly common. It's something called normalization. We take a value that we want to normalize, create a range of the minimum and maximum values, and then do a calculation that takes the value and minuses the minimum value in the range, then divides this value by the maximum value in the range, minus the minimum range value. Sounds incredibly confusing if I say it out loud like that. So let's add some real values in first to try and make sense of this. I'm going to type out the actual code and then I'm going to replace some of the values with real numbers. So I'm going to start off by writing the word function to create a new function, and I'm going to call this norm, short for normalize. And this is going to take 3 values: the mouse position, the minimum value in the range, and the maximum value in the range. We're then going to add some curly brackets, and all I want this function to do is return a value. Now, when we're returning the value, we basically want to create almost a fraction. So we're going to take the mouse value and the maximum window width and basically divide them by each other. To make sure that this is always between 0 and 1, we're going to represent it a bit like this. I'm going to do value minus min, and then I'm going to divide it by max minus min. Again, we're going to go through this a few times just to make sure that we understand it. The next bit that I'm going to write isn't going to be real code because I'm going to be passing in and doing these calculations myself, so I'm going to comment it out to make it a little bit easier and to make sure the editor doesn't throw any errors. So if you imagine that I'm calling this function called norm, and I'm going to pass it, I would just write like this rather, and I'm going to pass it some values. So imagine that our page X value is at around, let's say, 870. I'm then going to pass it the minimum value in the range, which is going to be 0, followed by the maximum value in the range. At this window size, I believe it was around 1430. So I'll go ahead and add that in there. What the function is then doing with these values is this sort of maths. So we're going to take the value and subtract the minimum. So the value is 870 and the minimum value is 0. And the function then divides this by the maximum value, which is 1430, minus the minimum, which is 0. If we look at what this actually does, which is 870 divided by 1430, we can see that this value is always going to be a fraction. So it's going to be, if I work this out, my maths isn't so good, let's use a calculator for this one. You can see here we're going to get a number that is sort of halfway between our screen points. So it will return a value that looks similar to this. So that's how our function is going to work, and it will work with any number and any screen size, which is absolutely perfect. So we need to continue on with this. Let's now try and add and call these values, or call this function, inside of our code. I'm going to go ahead and delete those notes for now. And let's just do another constant. Let's call this the normal. And we're going to make it equal to our norm function. And what we're going to pass into here is our value. And then for the minimum value, we're going to use our range array and pull out the first value, which is going to be 0. So we're going to pass it a 0 into those square brackets. And then we're going to use the second value, which is going to be window.innerWidth. So I'm going to add 1 in between those brackets. To check that this is giving us what we want, let's log it out and test it in the console. So console.log, and I'm going to add normal inside of there. Okay, let's republish and check it out. Right click, head to our console, click on console, and let's start moving around our mouse. Now we can see that as we move the mouse across, the number gets larger, but now instead of it being a value that is really, really big, like 1,200, we're now getting a decimal or a fractional number that is between 0 and 1. So that's perfect. The last bit of the puzzle is to apply our new normalized value to the U volatility of our plotter animations. Let's give this a go. Final line. Again, I'm going to delete my console.log now because it's not good to leave those in there. And just below this value here, we're going to write scope.material.uniforms .u volatility .value and just set it to our normal. Okay, let's test it out for the final time. Okay, so we can see that finally the mouse is actually doing stuff. As we move it over to the right hand side, our text gets more and more volatile. Now, if the volatility is a little bit too much for you, feel free to play around with that equation. For example, we could divide the normal value by 2 if we wanted to kind of halve it so the volatility isn't too extreme. But once you've done that, and if it all works, that is the end of our tutorial. Congratulations, and if you have any questions, feel free to ask. Thanks very much.